presenter. I invite Mr. Kang Wing Chan from Malaysia. He will present entitled Retrospective Analysis of Volatile Organic Compounds in Drinking Water. You have a 15 minutes, please.
Hi, a very good morning to all of you, ladies and gentlemen. In the world of environmental monitoring, we constantly strive for comprehensive understanding. We design our protocols, we select our analytes, and we even analyze our samples in the lab. But when I flipped through the results in my lab, and I found out something is wrong with the data. What's going on? A ghost in the machine? Of course not. There was a signal screaming for attention, and now that the environment throws us a curveball, a compound that is not on our most wanted list appears in high concentrations. So ladies and gentlemen, I'm Chan Kawing, chemist from the Department of Chemistry Malaysia, specifically from the Water Quality Division. And today, you and I will be looking at the data of volatile organic compounds, or VOCs, in more than 1,000 samples analyzed in 2024. And in the next 10 minutes, around 10 minutes, I'm going to take you through three main sections of my presentation. In the first section, you will gain deeper understanding of what VOCs are, and also the maximum limit permitted in drinking water. And in the next section, I'm going to show you our protocol and procedure to be used in our lab in Malaysia. And the last section, which is the gist and also the core part of today's presentation, we are going to look at or find out what went wrong over the 6-month period in 2024. So what are VOCs? A VOC is literally a compound or a chemical that escapes from its source at room temperature very easily without much effort. Because it doesn't like water, and therefore it has low water solubility, and thus creating high vapor pressure above its source. So such VOCs are benzene, toluene, and so on. In fact, we have encountered VOCs since within our household since young. For example, in the bathroom, some domestic items could have released VOCs such as toluene, xylene, or styrene, and so on, and probably they could be in low concentrations and therefore it didn't do any harm to our body. And for your information, some VOCs can be produced from the water treatment process. For example, the water treatment operator adds chlorine into water to disinfect or to kill germs, and the extra amount of chlorine can react with organic compounds, thus creating or leading to the production of chloroform, bromodichloromethane, dibromochloromethane, and bromoform. And these are collectively called trihalomethanes or THMs. For your information, on a routine basis, we only analyze these 4 compounds and report these 4 compounds because there is a request from our client, Ministry of Health, MOH in Malaysia. While other VOCs such as benzene, 1,2-dichloroethane, trichloroethane, or tetrachloroethane, we analyze them and we only report them when there is a request from our client MOH. And these compounds could be from the industrial processes or industrial discharge, especially from, for example, the metal degreasing operations. And it is also scintillating for me to highlight one more compound, methylene chloride. It is better known as dichloromethane or DCM. It's from paint strippers. And this compound or this better known as a solvent is one of the most undesirable organic solvents to be used in lab because it's very dangerous and it's very hazardous. And why does it matter? The burning question is, why does it matter for us to monitor the VOC levels in water? Because VOCs are toxic. They can cause cancer, they can damage our organs, and they can even kill aquatic life. And we do VOC analysis out of the need of complying with the international standard EPA. In fact, in Malaysia, we do have our own standard. It is called Drinking Water Quality Standard, and this spells out 25 VOCs to be monitored in Malaysia. On a routine basis, we monitor these 25 compounds, but unfortunately, our client only requests us to analyze 4 compounds or report 4 compounds, and they are THMs. And sometimes we also receive requests from our client to do further study and to analyze another 4 compounds, another 4 VOC compounds. So for your information, we analyze all the 25 compounds, but we only keep them in the file, and the story ends there because there is no request for us to report them. And therefore, the famous compounds like toluene, methylene chloride, if they are present in water, they just end up in a file. So next, let's see how we do VOC analysis using Purge and Trap GCMS. First of all, we need to prepare 2 intermediate mix standards at 50 ppm and 4 ppm from a concentrate ampule containing 60 compounds, although we are just using 25 compounds. So from these intermediate mix standards, then we prepare a series of calibration standards, 6 calibration standards from 1 ppb to 200 ppb. And here we construct a linear calibration curve for each VOC. Not to forget, we also need to prepare a calibration check standard and at 50 ppb and also a QC sample at 10 ppb. And to ensure or to check the stability of the instrument, then we prepare an internal standard and 2 surrogates in a mixture. And from this mixture, we prepare a dilute version of it at 12.5 ppm. And during analysis, we just inject 2 microliters of this dilute version, and they are mixed with 5 ml of water, leading to the final concentration of 5 ppb in the water. All right. Not to forget, we need to perform BFP tuning as mandated by the international standard EPA. So how it works, the system injects one of the surrogates, bromofluorobenzene, into the system, and then it analyzes the abundances of a few selected masses if they fall within the acceptance criteria, and therefore the system is deemed or considered suitable for analysis for that day. So let's see the functioning of VOC analysis. The system takes only 5 ml of water sample and then 2 microliters of the mixture of internal standard and also 2 surrogates in the mixture, and they are mixed in a sparger, and with the aid of heating and also bubbling, all possible VOCs in water are evaporated and then retained in a trap and at a higher concentration, and these VOCs are released or dissolved and injected into a GCMS system for analysis. And these are the calibration curves for VOCs, and we strive to get an R value or an R squared value more than 0.99. And to verify the identity of each peak, we need to rely on the retention time, RT, and also 2 qualifiers for each peak. Likewise for surrogate. All right, now this is the result for VOCs. And in order for us to accept the results, we have to ensure that the CC sample calibration check standard and the QC samples have achieved 70 to 130% recovery. Likewise for surrogate, at least one of the surrogates should have achieved 70 to 130% recovery. And the Q value denotes the compliance of RT and the ion ratios for positive confirmation. So it has to be more than 70 for positive confirmation for each peak. All right, in 2024, we analyzed many samples, but for today's presentation, only 1,807 samples were isolated for retrospective analysis. And for illustration, these samples are better represented in a box plot format, and it will be easier for us to single out any sample that has an analyte or VOC containing which is above the maximum limit. For example, bromodichloromethane, the maximum limit in Malaysia is 60 ppb. As we can see here, this is a bar for this one. None of the samples showed more than the maximum limit. They are below the maximum limit. Similarly, for bromoform and dibromochloromethane, and this is the bar, and this is the bar, and the maximum limit is 100 ppb, and none of the samples show more than this limit. Unfortunately, for chloroform, the maximum limit is 200 ppb, and there was one sample above the limit, and we have reported it accordingly to the Ministry of Health. So how about the rest of the samples? It is very fortunate that none of the samples show more than the limit for the rest of the VOC, except for this one, methylene chloride. The maximum limit is 20 ppb. As we can see here, many samples show above the maximum limit. It means 166 samples recorded 21 to 1007 ppb methylene chloride in drinking water. In other words, 9% of the samples were contaminated. So ladies and gentlemen, through today's presentation, I would like to call upon our local authorities and also our client to include methylene chloride on the routine monitoring list so that we can assure that the water we drink is safe for consumption. Thank you very much.